A conditional statement is an if-then statement. So, for example, if your parents say, if you want to go out with your friends, but your parents say you can go out with your friends if you clean your room. You can write it as if you clean your room, comma, then you can go with friends. This is a conditional statement. You can only go with your friends based on the condition that you clean your room. So the hypothesis part of an if-then statement is the if part. So in this case, the hypothesis is you clean your room. That the hypothesis is the first part, whatever follows the if. So it's the if part. So anything after the if, you need to write down for the hypothesis. The conclusion is after the then. So the conclusion would be after the then, write everything down after the then. So you can go with your friend is the conclusion. The truth value is whether or not the statement is true or not. So is the statement true or false? Okay, in this case, if your parents tell you if you clean your room, then you can go with your friends, that's a true statement. But sometimes not all conditional statements are true. I just want to add too that conditional statements can be written as this. If you see this notation, this means if P, then Q. Or P, if P happens, it implies that Q happens. Or P implies Q. So in this case, your P would be you clean your room, and your Q would be you can go with a friend. So P is the hypothesis, and Q is the conclusion. In order to write each conditional statement, write each as a conditional statement, you have to turn it into an if-then statement. So this first one is not an if-then statement. An integer that ends in 0 is divisible by 5. So I have to carefully add an if and then. So I'm going to add if an integer ends in 0, then it is divisible by 5. Okay, the second part, I have to identify the hypothesis and the conclusion. So the hypothesis is everything that's after the if until the then part. So my hypothesis is if an integer ends in 0. My conclusion is it is divisible by 5. So this is the conclusion part. The next one I already wrote out as a conditional statement. You need to be careful with the conditional statement that you don't want to start it with an if. So I don't want to say if it is a square, then it has 4 congruent sides. I don't want to start my sentence with an if. So instead I say if the object or if the shape is a square, then it has 4 congruent sides. So again, the hypothesis is everything that is after the if. So the object is the square is the hypothesis. And then everything that's after the then is the conclusion. It has 4 congruent sides is the conclusion. I wrote out the next one too. If you have all birds have wings, you can write it as if the animal is a bird, then it has wings. Again, I didn't want to say if it is a bird, then it has wings. I just don't think that sounds as good in English. So the hypothesis is follows after the if. So the animal is a bird is the hypothesis. And everything after the then is the conclusion. It has wings is the conclusion. Okay, a Venn diagram shows relationships among different things. So in algebra, we did a Venn diagram for number systems. We said all natural numbers were whole numbers, all whole numbers were integers, and so forth. So now we're going to take conditional statements, or make them into a conditional statement, and then write a Venn diagram for it. So all Grand Rapids residents live in Michigan. So to change that, you would say if the person lives in Grand Rapids, then the person is in Michigan. Or if the person is a resident of Grand Rapids, then the person is a resident of Michigan. I would take both answers. So if everybody in Grand Rapids lives in Michigan, you need to put Grand Rapids on the inside of your Venn diagram and Michigan on the outside. This automatically means that if you live in Grand Rapids, then you're inside Michigan. The second one, if something is a Cocker Spaniel, then it is a dog. So all Cocker Spaniels are dogs. So the Cocker Spaniel needs to go on the inside, and the dog is on the outside. That's how you draw a Venn diagram. So that if you notice the pattern, the if part is inside and the then part is on the outside. The converse of a conditional statement is you switch the hypothesis and conclusion. So if you have a conditional, oh, I ran out of room. If you have a conditional statement that's P implies Q, this is read if P then Q. The converse switches it around. So if Q then P. You have to go backwards. So the first one, write the converse of each conditional and then evaluate its truth value. Truth value means to figure out if it's true or false. So to write the converse, x equals 2 is the hypothesis. The absolute value of x equals 2 is the conclusion. So I'm going to flip-flop these. It looks like this. If, now the conclusion, the absolute value of x equals 2, then x equals 2. So now we have to figure out if that's true or false. So if you remember from algebra, the absolute value of x equals 2 has two numbers, because the absolute value is a distance, a number is from 0. So actually the absolute value of x could be 2 and negative 2. So this actually is false, because x could be negative 2. So the truth value is false. Okay, for the next example, I switched the hypothesis and conclusion around. So, and I included an if. So if two lines are parallel, then they intersect. I switched it around. I didn't want to write if they are parallel, then the two lines intersect. I just don't think that that is very descriptive English-wise. You don't want to start out beginning of a sentence with a pronoun or it or something that, you know, it's not really specific about what you're talking about. So I said if two lines are parallel, then they intersect. So now I need to figure out if this is true or false. So if two lines are parallel, they intersect. That's definitely false. The definition of parallel lines is they don't intersect. And the last one, write the converse. So again, we're going to switch the hypothesis and conclusion. So if a equals 5, then a squared equals 25. And determine its truth value. So if a equals 5, does 5 squared equal 25? Yep, it does, so that's true. The truth value is true. However, I just need to add this, having taught algebra last year, the original statement is false. If a squared equals 25, then a could be 5 and negative 5. The original statement is false, but the converse is true. Okay, 4, show that each conditional, so we're not flipping it around like before with the converse, is false by finding a counterexample. So we learned chapter 1 what a counterexample is, something that disproves it. If lines do not intersect, then they are parallel. So we need to think of lines that do not intersect that are not parallel. So last chapter we talked about special types of lines that never intersect and are non-coplanar. So these lines are skew lines. So skew lines are examples of lines that do not intersect, but they're not parallel. And then letter B, all numbers containing the digit 0 are 10. So examples of this are 50, 60, 10,000. But I need to find a counterexample. All I need is to have a 0 in the digit, but not have the number divisible by, or have a digit of 0 in the number, but not be divisible by 10. So here's a counterexample. 506. It has a digit of 0, but it's definitely not divisible by 10. So this is my counterexample.